Hello and welcome to the second ever video episode of our now monthly podcast, Break It Down. If you're watching on YouTube, we are very pleased to have you. If you're listening on any of the other podcast platforms, we invite you to check out the video on youtube.com/IFL Science Official, as it will include extra videos from the subjects we're about to talk about. I'm your host, Eleanor Higgs, digital content creator for IFL Science, and I'm joined as ever by
senior science writer Rachel Funnell.
And we've got a whole 4 weeks of science news to discuss. So let's get started. Break it down.
First off this month, I'd like to take us to Skull Island. Do you fancy going there?
I don't know if I do. That sounds quite ominous.
I mean, yeah, I suppose it is a slightly perilous place. But myself and managing editor Katie Evans were invited to the preview of the first 2 episodes of Monarch Legacy of Monsters. So for anyone who hasn't seen the series, it's from Apple TV and it features famous faces including Godzilla and King Kong. We also got to see 2 of the other famous faces in it, the actors that play Lee Shaw. So that's father and son duo Wyatt Russell and Kurt Russell. And I won't give too much away if you haven't seen the second series yet. But what I will say is that if you're a fan of giant sea monsters, this is definitely the show for you. And we've got a little teaser clip for you.
Oh, very exciting.
We gotta go back. This is the only way. We have to go. Don't make a sound.
This is my first story this month, and it was written by Stephen Muntz, and we've got a new, probably world's largest coral colony, which is very exciting.
Love this. I saw the diagram and it is quite hard to get your head around.
It's pretty impressive. So this was found actually by a mother and daughter team of citizen scientists, and it's a single coral colony, try saying that 5 times fast, on the Great Barrier Reef, and basically it stretches more than 100 meters, which makes it the longest ever documented. And if you look at the pictures and the videos, we'll put a little clip in, it is vast. Like 100 meters to me doesn't seem that far. I think Usain Bolt sprinting. Was it the London Olympics where he rose to fame? But that's what I think of. It doesn't seem that far, but it just goes on and on and on. And it covers an area of 3,973 square meters, which again, doesn't mean that much to me. But Stephen is a football fan and he's converted it into football pitch size. So it's longer but smaller than area for a standard football pitch or soccer pitch if you're in the US. And rugby pitch is bigger, apparently, according to Stephen. And then apparently the ovals for Australian rules football are 3 to 6 times the colony's size. So it's vast, but it's not as big as an oval for Australian rules football, in case you were wondering. But this is pretty amazing because the people that discovered it are called Sophie and Jan. And like I said, they're a mother and daughter team. But they were doing a Great Reef census to sort of monitor the reef. They're citizen scientists. They're not sort of paid scientists, as it were. They stumbled upon this amazing, amazing coral. And there's a great quote from Sophie that says, "I knew right from the minute we dropped in it was something special. When I got in the water, I'd never seen a coral growing like this before. It looked like a meadow of coral. It just went on and on. What is really impressive is that they had the previous sort of record holder is only a third of the size. So
Wow.
it's like really trumped it. And then they discovered another one in Bali, but covers a similar area, but it's not as long. So this one is the true winner. And it's a species of Pavona. And it sort of looks like kind of not very tall, white little marshmallowy bumps that go on and on and on.
Yeah, well, I like the sporting comparisons that Usain could make. Short work of it. It might not look like much on an Australian football game, but 3 times bigger than the previous title holder. I think that's all you need to know. That means that we have vastly increased our understanding of how big these things can be.
Yeah, and what they're doing is they're keeping the location secret. And you might think it'd be quite hard to hide a giant coral that sort of size, but given that the Great Barrier Reef is absolutely vast, it's sort of not too much of a challenge to hide it. It actually includes 2,900 reefs, which stretch a distance of 2,300 kilometres. So hiding this one in the middle doesn't seem to be too much of a challenge. And it's absolutely amazing. The good thing as well is that this reef seems to be thriving, like especially sort of in these times of coral bleaching and ocean acidification events. This one seems to be doing really well, and I think it's because it's in quite deep water, so it's sort of a bit less vulnerable to extreme temperature fluctuations, and it's full of fun little fish and all sorts. So yeah, I'm very pleased that we found it and that it's thriving, and that we have citizen scientists that can discover stuff like this.
It's a strong start for mother-daughter, father-son duos so far.
Yeah, absolutely. What have you got up next?
Well, I've got some science news that, sometimes we get these stories and they're quite hard to know how to handle. And I think this month's developments surrounding asteroid 2024 YR4 encapsulates this feeling. So our space editor, Dr. Alfredo Carpinetti, has been giving us the updates on this, and it's taken us on a real roller coaster. I mean, back in early 2025, we were getting worried that it might smack us. This thing is slightly wider than an Olympic swimming pool, but that's plenty big enough to cause problems. Then that danger shrank, but a new possibility became quite likely, that it might punch the moon in the face in 2032.
Which is really what we were all hoping for.
I mean, I'm sorry, moon, but it is true. Because, it might not sound great. It is our moon after all. But astronomers were pretty adamant that it would be a great opportunity because we'd get to observe this really big impact from the safety of our planet. And it would have had the potential to add a new crater. So that's like changing the face of the moon. But alas, the dream has died.
No.
We have been keeping an eye on this sneaky little space rock using JWST. There was like a really narrow window in February where we could spot it before it was going to disappear again until like 2028. The measurements that they took then revealed that the space rock will miss the moon by 21,200 kilometres with an uncertainty of only 700 kilometres. So basically, there's just no chance.
That's so sad. I know, this seems horrible to the moon, but I was really rooting for like a 2032 viewing event where we all watched it smack onto the moon.
I think I've been the only one in the team who's been sort of routinely being like, but guys, the moon. But I can understand the disappointment for scientists having read Alf's update, because he was talking about how, depending on the equipment that we could have used, it's possible that when it hit, the measurements that we got from that could have told us about like the moon's interior, which is something that we don't currently know that much about.
Oh, that's cool.
We would have got to see the impact from Earth. It would have been visible as like a flash, one representing an impact equivalent to 6 million tons of TNT.
Oh, blimey.
And all of the stuff that all of that explosion like lifted up, that could have given us a meteor shower that would have lasted for days. But there is some good news. Firstly, it demonstrates that planetary defences are good and working because, we saw this guy coming and we've been able to track its movements ever since. And they were, I remember back in 2025 when there was that concern about whether it was going to hit us, they were making plans as to how we could reduce the negative impact of that. So, good to show that that works. The other bit of good news for anyone feeling disappointed that they won't get to see an asteroid punch the moon in the face is that our animator, Phil Brain, has put together an artist's impression of what that might have looked like. Here it is.
This is a really fun one that I actually wrote earlier in the month, and it's all about Mistral the whale shark. And I'm going to be honest, I love him and his many adventures, but I will let past Eleanor take it away all about Mistral because this is just so cool.
Hi everyone, Eleanor here, just coming on to tell you all about Mistral the whale shark. So whale sharks are super cool anyway, but this one in particular has been up to all sorts. So it was first seen in Madagascar in 2019 when it was only 4.5 meters long. I mean, I say only, but that is still a pretty big whale shark. And then it did whatever it wanted to do for a long time until August 2015, when it rocks up off the coast of the Seychelles Islands, which, for those of you not super into geography, is a journey of 1,200 kilometers across, and it also is the first verified re-sighting of a whale shark moving from Madagascar to another country in the region in the Western Indian Ocean. So this is really cool. He swam a heck of a long way. And what's also interesting about it is that he was first identified using like tour operator photos, citizen science photos. Some Malagasy students took pictures of all different whale sharks in the area, so they knew what he looked like. And then they could compare that from all the way back in 2019 to the photos taken of him in the Seychelles last year. So then they could identify that it was the same whale shark. I also really want to know what he was up to for the 6 years in between, but I guess we'll never know. But it's really cool now that we can see where he's going and where he might go next. Back to future me.
Okay, are you ready for human ancestors?
Never, but take it away.
So some big news that's landed this month is that we may have found the oldest human ancestor somewhere where nobody was expecting it. This news comes to us from writer Ben Taub, and is big because we've long thought that our story, so that's that of the hominins, began in Africa around 7 million years ago. But possibly not, because we may have just found the remains of an even older hominin in Bulgaria. And so if this is confirmed as a hominin, this find would suggest that our earliest ancestors emerged in Eurasia before migrating to Africa due to climate change in the late Miocene. So before this news came along and confused everyone, it was thought that the oldest hominin was the genus Aurorin, which was found in Kenya. This was a prehistoric ape-like creature, but it had a key difference from chimps, is that it walked on 2 legs. So this is known as bipedalism. But step aside, says, I'm going to get this wrong, Gracopithecus? Gracopithecus? We'll go with one of those.
I believe you.
Its thigh bone was found in the Asmaka archaeological site in Bulgaria. It's important to note, as I said, that we are still waiting on confirmation that it is indeed a hominin, but it's thought to have come from a female individual who weighed about 24 kilograms. And there are aspects of the leg bone that makes us think that she was walking upright. That said, they don't reckon she was doing it all the time. It was probably more of a combined approach, so
Okay.
a bit of quadrupedal locomotion. So, I mean, what I was imagining, I was like, okay, well, this is what then a sort of transitional stage. You're no longer really that good at climbing trees, but you're also not that good on the ground, and it kind of sucks for these guys. But that shift was probably driven, as I say, by climate change, so the forest would have been disappearing, and desert habitats would have been becoming more common. And so you had to either get up on your 2 legs or fall behind.
She was also tiny then. If she was only 24 kilograms, she would have been really a dinky little ancient
Yeah,
ancestor.
I would have looked like a giant next to this person, I feel.
Especially if she couldn't walk on 2 legs as well, then she would have been like crouched.
Yeah, I mean, it sounds like me on a tired day, to be honest. But
Yeah,
I've
so
got a lot of
true.
sympathy for these guys. But yeah, and then if these are indeed the earliest hominins, then it's possible that they migrated to Africa, and that is then where the Aurorin appeared, and all subsequent hominins since, including us.
That is very cool that they can tell all that from potentially tell all that from one specimen. Like, it could just completely rewrite everything we know about really, really early ancestors.
Well, this is the tricky thing of working from fossils, right? Like, you find pieces, you can only figure out so much. A thigh bone is pretty useful when it comes to understanding how an animal was moving along. They spoke about something on it called the neck and how this is slightly longer. So that's something that you tend to see in animals that walk upright. So that's how this specimen has been able to sort of change our mind. It also, I know one of our other writers, Tom Hale, likes to point out how often we're thinking an awful lot from just finding a single bone, because you know there is a lot of gap to fill in when you've got this just one speck of piece. But I think it's amazing because it goes to show you, like, statistically how unlikely it is that we could have found that fossil, and now it could completely change our understanding of the origins of ourselves. So
Let's send
nice one, Bulgaria.
Yeah, everyone to Bulgaria. All the archaeologists. Let's see what else we can dig up.
What's your next story?
This is a very fun one, written by Holly Large. We thought that these little tiny marsupials had been extinct for 6,000 years, quite a long time. Turns out we were wrong, and they've just been chilling in the forest.
I always love it when animals do this. They're just like, just kidding, guys. I've been here all along.
Yeah, you think, like, yeah, you could be good at avoiding detection, you know, you could be like hiding, whatever. But to hide for 6,000 years is pretty impressive. So it's a bit like your ancient human ancestor. These two marsupials were only known from fossil specimens. So there's one called the pygmy long-fingered possum, and that hailed from Pleistocene era Australia. And then there is the ring-tailed glider, which was known from Pleistocene or sort of early Holocene New Guinea, and they think that both of them vanished around the same time, except that they didn't, which is kind of embarrassing, but very, very cool. So thanks to a combination of photographs from local people, fossil fragments, and even a rare specimen that was collected back in 1992, they found them living on an island off the coast of New Guinea, I think. It's called Volgtop Peninsula. So yeah, the relationship between the researchers and the local people was really, really important. And they basically set off into the forest, I think. But the return of both the possum and the glider, like back from the dead, as it were, has earned them membership to what they call Lazarus taxa. So these are species that they thought were like really long gone, and they've been discovered. And like basically finding one Lazarus taxa is like exceptional. And then to find two is just like mind-blowing to everybody involved. And these two little species, they have no close relatives anywhere else on New Guinea, and they don't really know how they ended up on the island. It could be that it sort of was an ancient piece of Australia that then eventually like broke off and became part of the New Guinea sort of area, but nobody is 100% sure. What they are sure of, though, is that they are absolutely stinking adorable. I love it when we find stuff and it's really cute.
It also looks kind of equally shocked to have been found. It's like,
oh yeah.
It's been getting away with this for such a long time.
The ringtail glider is literally like shook. It's got huge eyes and it just looks really, really surprised to have been discovered. But yeah, but I think part of the thing that they found used by talking to local people is that potentially they could find even more. Because New Guinea is pretty impenetrable. That's quite hard going to like discover stuff. So they wouldn't be now potentially as shocked if they found something else lurking in the rainforest. But yeah, absolutely amazing that these little species. I think it's really cool, like the coral story in this story. This stuff has been there the whole time. And even now in 2026, we're discovering it, which is just so fun for us.
Yeah, I always imagined that there's nothing like that big left to find. And then just like, oh, just lurking under the water, there was this enormous monster. Real life Pokemon. I love it.
Real life Pokemon, yeah, absolutely.
So I was lucky to get to do quite a lot of cool interviews this month. Hard to pick a winner, honestly, but I was blown away by the chat that I had with Dr. Steve Boyd, who spent 10 years searching for ghost elephants in the Angolan highlands. His story, and that of the incredible master trackers who made his quest possible, features in a new film directed and written by Werner Herzog, and it's called, surprise, surprise, Ghost Elephants. It's an incredible film. There's so much history and culture and an amazing search with an incredible ending. But what I want to show you is a clip of our discussion talking about this insane grub that the master trackers use for their poison tip arrows. It's tiny, and yet it's powerful enough to kill an elephant. So here it is.
It's a little beetle. It's about the size of a ladybug, a different shape. I've seen them. They will go for small marula trees and euphorbia trees. And you will notice that the tree's been denuded of its leaves. Even the leaves look a bit smaller than they should because they've been nibbled on the edges. That's the grubs, these tiny grubs. They're almost kind of like twice the size of a maggot. Now they will go then down the tree into the ground. They're about a meter below the surface, and they make these little sand cocoons. Now, I've held these cocoons. You dig them up. I mean, it's like holding, I don't know, like plutonium or something. I mean, it's just. You touch that, if you've got a scratch on your hand and that gets into the wound, it's highly likely you're going to die. I mean, in the film, Werner says just a few of these grubs would kill an elephant. When I asked him, he said, no, just one grub, paint the insides onto the arrow shaft. If you shoot the elephant in its trunk, because there's so many blood vessels and muscles in there, it'll just take 4 days for the elephant to die. For any other animal, because they're much smaller, they die the same day or overnight. But it is extraordinarily potent. They use wild asparagus and one other herb. Those together, the one will shut down your kidneys. So if you are urinating, it's black with the blood vessels that are being exploded by the hemolytic poison, the grub's poison. It just makes your blood boil and fall apart. And the other one is like soap. It's a vine that grows on the ground. You can actually wash your hands with it. It's very soapy, but a tiny bit of that into your bloodstream makes your lungs foam. So, when that poisoned arrow, which has got those 3 poisons on it, the primary one being the grub, when that pierces your skin, your lungs are going to foam up, your kidneys and your bladder is going to shut down, and your blood's just going to boil apart, and you die a very painful death. Kui got shot in the arm and managed to save his arm by just cutting into the flesh to bleed it out before it got to his heart. Because once it gets to your heart, there's no hope for you to survive. Ricardo, the translator in the film, you see him quite often. Ricardo, him and his brother shot a kudu, a big antelope. He retrieved the arrow just to pull it out of the flesh, and then they slaughtered the animal and carried it back home. He didn't wash his hands before eating that night, but he had 6 hours prior just touched the arrow. He ate his food with his hands with no utensils, and he was bedridden for 6 months because of that. That's how potent it is.
But yeah, I just think that quote about it's like holding uranium. I would go nowhere near this thing. They were all talking about like handling it and passing it around. I'd be like, thank you. No, thank you.
When he was like, it just boils your blood and then your blood like disintegrates, I was like, you can keep it. You do whatever you want to do with that, but I'm going nowhere near.
Absolutely killer triptych of, what was it? Something like asparagus that does terrible things to your kidneys.
Yeah.
This little poisonous grub, and then a plant that on one side you can wash your hands with it.
Yes.
But in the next moment, it's making your lungs all bubble up. I was like, wow, nature turns on you when it wants to.
Well, it's also amazing that it's so small but so potent. Now I'm scared. Angola Highlands, you can stay right where you are. Thank you very much.
So just a reminder to everyone to be nice to beetles, because you never know what they're packing.
So up next on my list is a pretty incredible story. I'm absolutely blown away by this, as I am usually with all medical miracles. I'm going to call it a miracle. I think it's justified. This was written by Laura Simmons, and baby Hugo is the first UK baby born after a womb transplant from a deceased donor.
Wow. I mean, congratulations, Hugo. Congratulations, mother of Hugo.
Yeah.
What a win.
What a win. So Hugo's mum is a lady called Grace Bell, and she was born without a womb because she has a condition I'm definitely going to mispronounce called Mayer-Ratansky-Koester-Hauser syndrome, or MRKH, which is a lot easier to say. And in this syndrome, it's a genetic condition where the uterus and the upper vagina don't fully develop. And there are different types, and other organs can be affected depending like what sort of type you have. But mainly the sort of signal of the condition is the lack of a functioning uterus, meaning that it isn't possible to become pregnant, which is where these incredible uterine transplants have come in. And I'll be completely honest, I didn't even know that we could do this. I think it's...
No, I was the same when I heard this story. I was like, I didn't realise we had begun, let alone that we were near success.
That this was working. So apparently the first birth following a womb transplant was in 2014, so we're way behind the mark. And in 2015, there was a baby that was born from the same womb that had carried his mother, because the baby's grandmother gave her daughter her womb, if you see what I mean.
Wow.
Isn't that mind-blowing?
Yeah.
Yeah, so we have been doing this for a little while. Fortunately, the parents of the lady that died agreed to give the womb of that donor womb to Grace. And this is where it really blows my mind, because you think, if you've never had a functioning uterus, to some then, like your body to be able to receive one, and then Grace underwent IVF, an embryo transfer, and then she was pregnant. And then, you know, she had a C-section, and now she's got a baby called Hugo. And it's just absolutely mind-blowing to me that that could ever work and be successful.
Yeah, I'm always amazed by the kind of cooperation of donor organs.
Yeah.
Like, they were in a body, they all were always in that body, and they knew that body, and then you take it out and you put it somewhere else, and it's like, I guess I'll just get back to work.
Yeah, I'll just carry on.
Of all the things that organs can do, like building another human seems like a pretty sizable job, but then you can just get this incredible cooperation between a donor organ and the person who's received it. It's amazing.
It's also amazing to me because Grace never had like a functional uterus. So it wasn't as if she had the, like, I don't know, internal plumbing where it was all working. She just couldn't get pregnant for whatever reason. It never worked. So they just took out the old one, popped a new one in, and then Bob's your uncle, she had a baby. It just, medical stuff is just so incredible to me. Well, on that good news, what have you got coming up next?
Well, I did say that I got to do some really fun interviews, and here is another. I've been out and about a few times this month doing some stuff ahead of the release of Project Hail Mary. I'll start by saying phenomenal movie.
Oh my God.
The first impression I got when I sat down watching it was like, it feels like I'm inside a big kaleidoscope. It's so like sparkly visuals, like space, cool lights.
I'm going to see it next Wednesday. I'm so excited.
Yeah, thoroughly recommend one for the cinema, I have to say. It was quite funny as well because I was sat in a tiny like press theatre watching it. So it's like you and three other people and you're all quite close to each other. And like I was crying, I was laughing. Both things happened several times. It's got everything. But yeah, such an experience. And of course, it's a phenomenal movie that comes from an equally phenomenal book by author Andy Weir. I just love his story alone. I mean, he was a software engineer for like 20 years, and then he had this huge hit success with The Martian, and now we're getting to see another of his books on the big screen. So I caught up with Andy to find out how he approached creating Erid, which is this habitable planet for these really weird aliens called the Iridians. So take it away, Andy.
Well, I started off with a real exoplanet that I chose, which has since been proven to not exist, but let's get past that. At the time I wrote it, it was believed that it existed. It's a planet very, very close to the star 40 Eridani, so close that it orbits once every 46 days. I mean, so it's considerably closer to its star than Mercury is to ours. So I was like, well, that's where I want a whole active biosphere to exist. So, and it needs liquid water. So how can something be that close to a star and have liquid water? And my answer was, well, it'll be really hot, but it'll also have a tremendous air pressure. Because if you increase the air pressure, you increase the boiling point of water. But It's kind of hard to have a really thick atmosphere when you're right next to a star because the solar wind acts like a sandblaster that'll pull your atmosphere off. So I said, like, there's two ways to fight that. One is to have really heavy molecules in your atmosphere. That's why Venus, which is pretty close to the sun, has like 90 atmospheres of pressure at the surface, because it's mostly carbon dioxide, which is a really heavy molecule. I decided ammonia for arid. Ammonia is going to be what its atmosphere is mostly made of, because we see that all over the place in our own solar system, in like Neptune and Uranus. Whatever. We see it in gas giants all the time. So I'm like, okay, so you've got like 29 atmospheres of ammonia plus, it's really hot. It's like 200 degrees Celsius. And also to protect it, you need a really fast rotational rate, which gives you a really strong magnetic field, which helps deflect it around the solar radiation, all that. So then I'm like, all right, now that's the environment that at least has some liquid water. Now what life can I do? And I'm like, well, the life would be, the atmosphere is so thick, I don't know if the sunlight would get to the surface. So instead, their atmosphere would act kind of like an Earth ocean. There'd be things in the upper atmosphere that absorb light and reproduce that way, and then things below them that eat that, and then things below them that eat that. I mean, light only gets, like 20 meters or so into our ocean, but we have things living way further down than that. That's why when you get all the way down to the surface, you've got the Iridians, which are like the apex predators of their planet, just like we're the apex predators of ours. And so I had to design their morphology and biology around those constraints. Because I've already defined that their atmosphere is like ammonia. Like they're not exchanging gases with the atmosphere. It's not like there's plants doing their thing and animals doing their thing like we have on Earth. So the only way to exist would be to have plant-like cells and animal-like cells doing that exchange internally. Like, so basically an Iridian's body is like a little biosphere internally. And like I said, it only opens up to like gather food. As long as it can keep getting energy, it can maintain everything it needs for that biosphere.
He just seems like an absolute delight. I love that he's so enthusiastic, and he's like really thought it all through from a science perspective as well.
Well, I'm always impressed with authors because, like, I'm a writer. We spend all of our days like sat away working on our things in private. And then something big like this happens. And now Andy's being wheeled out of his writing room and having to perform in front of all of these press people. But no, he was so nice. And so like the enthusiasm for the science just comes like spilling out of him when he's talking. So I just loved it. And they were saying like that detail from the book helped to make the movie what it is, because there's so much to build upon. So yeah, you got to read the book, got to watch the movie. Just excellent.
I think for a book with literally like 2 characters, it's so good.
Yeah, it's always like thrilling, because one of the first questions I asked him was like, what's with all the like person alone in space? And he was like, I just like to take them somewhere where they can't call for help immediately. I was like, it's a very good story writing technique.
It's a good plot device. It's working for him, clearly.
Yeah, and it just, he said he finds it thrilling. I find it terrifying. But whichever way you go, it makes for a very thrilling experience.
Yeah, 100%. I can't wait to watch. I'm so excited. Go on then, Rach, what's this week's, or this month's even, I'm still not used to this, feature?
So this month's feature is a sort of intersection of got a bit of neuroscience, a bit of technology, a bit of futuristic weirdness. And I mean, I love this because I feel like at RFL Science, we all kind of fall into our natural niches, like based on our degrees and expertise. But at the same time, I feel like everyone in the team has a few like bonus areas that they kind of randomly...
We've definitely carved out
in-house
like
authority.
Yeah, strange things.
And I mean, for me, one of those weird niches is whether or not we can bring a brain back from the dead someday. It's something that I've spoken about a lot with Dr. Ariel Zalesnikov-Johnston, who is a neuroscientist and author of The Future Loves You, How and Why We Should Abolish Death. So it's all about this, like, trying to figure out a reasonably feasible way that you could, if someone dies, preserves their remains so that one day you could bring them back. And sort of a leading part of his theory is, well, all of the connections in your brain form this thing called the connectome, and essentially who you are, your personality, how you make decisions, all that kind of stuff is like preserved within those connections. So if you can lock the brain like that and find a way to maybe digitize it, then you could put that person online and have them as like an online personality.
Oh my gosh.
Is there a way of preserving it so that the brain tissue doesn't die and then you could bring them back that way? So you can understand why I was eager to catch up with him when I spotted this news study talking about how a team of scientists, they've been able to vitrify a mouse brain, freeze it at minus 196 degrees Celsius, defrost it, and then they still saw neural activity. And it's all to do with the way that they preserved it. Yeah. So vitrification is really weird and cool. It's this technique where you replace the fluids in a tissue with chemical solvents, so that when they freeze, they don't freeze into like crystals that are very sharp and tend to rip things apart. Instead, it solidifies into a kind of glass-like substance. So this overcomes the thing where, like, with some cryopreservation horror stories, you can freeze a human, but when you defrost them, they're just going to turn into goo, unless you do it properly.
That's horrid. It's making me think of those creatures that like survive extreme cold because they have some sort of like anticoagulant gene or like feature in their blood where it doesn't, you're right, it forms the crystals and then it just shreds through the DNA. But if it doesn't do that, then you're onto a winner.
Yeah. I think you're thinking of it's those wood frogs, isn't it? They've got antifreeze in them.
Yeah.
So they can just turn into a little rock, but no crystals form. So when they defrost, they haven't ripped up all of their cells inside.
Yeah.
But yeah, so this vitrification process, this team on this new study, they vitrified a whole mouse brain. So that's something that's never been done before. We've done it in slices, but not like a whole brain. They then sliced it afterwards, and so that they could monitor the kind of activity within the tissue. And I mean, it's worth noting that not every sample tested came back, but some of them did. And not only did the cells survive the whole vitrification, freezing, defrosting process, they actually retained the core features of their function. So that included neuronal excitability, synaptic transmission, long-term potentiation, and that last one is a central cellular mechanism that underlies like learning and memory. So these are like important processes that were able to survive this incredible technique. So Dr. Alexander German was one of the study authors, and he told me that this technology could kind of have a lot of applications in research, but also cryomedicine. So advances in vitrification could make us better able to preserve organs and other complex tissues, and then they could be transplanted. Because obviously it's always that thing you see. I remember when I was still living in London, you used to see these bikes with like donor organ stickers on the back because they've got to fly through town really fast or to get to the place in time. So if you could preserve them, you could effectively have like a whole bank of them rather than having to ferry everything around at great speed.
I see what you mean. Like it wouldn't be like a 2-hour window, whatever it is now.
Yeah.
You could keep it in a freezer.
Yeah, exactly. And then you're just like, just grab me one of those brains, would you? Like, pop it in this person.
I mean, we had womb transplants from a dead donor, so I feel like obviously, clearly, the next logical step is frozen brain transplant.
Well, actually, I spoke to Ariel about why a brain transplant is probably never going to be a thing. There's actually a podcast for that, so I'll link that in the episode description. But I mean, all of this obviously isn't without its caveats. The study itself points out its own limitations. I mean, for starters, it was only done in mouse tissues. There's always that. Scaling it up to larger organs and organisms is not a small step, so we have no idea if it's going to work any bigger than that. But yeah, as for Ariel's take on what this achievement means for the future potential of reviving a preserved brain, he said that it's very impressive because it is the first work to show any recovery of electrophysiological function, so brain waves, from a brain that has been vitrified, which is, that process of basically turning it to glass and then rewarmed. And while the study does make it clear that, we're a long way from doing this to larger mammals, it strengthens the case for sort of two key things. So one is that brain activity can at least be partially restored after a brain has been completely inactive and solidified. And the other is that it may be possible eventually to develop a protocol that can reversibly place an animal into stasis, where it's then vitrified at low temperatures, for whatever period of time you like, and then rewarm it and have some behavioural function, which is very sci-fi and very cool, I think.
That's very sci-fi. I'm just imagining if people have to leave Earth and colonize another planet, and you always have those like sci-fi things of people like in pods, and then they like get woken up when they get there. Now, next to everyone is going to be like their cat or their dog. They're going to do the whole lot. Somebody's horse just like floating in space.
Well, I mean, we were just talking about Project Hail Mary, and this is not a spoiler because it's literally the opener to the movie. Like, long-term space travel involved for him a lot of tubes in places where one would not like tubes. Like, maybe it could be nicer for the astronauts of the future to just freeze them completely.
Yeah.
And then there's no aging, there's no...
That's so true.
No tubes.
No tubes. I think the less tubes the better.
Yeah, so come on, you're in scientists. We need you to get on with it.
So cool. Like, as a concept, just really, really weird, let's be honest. But also, possibilities are endless.
Exactly. I think I like, my niches are kind of like, zoology is obviously my main one, but then weird death, creepy neuroscience-y stuff that inspires like books and things like that.
You're definitely death correspondent. Which I don't know.
I'm proud of it.
A title you enjoy.
All right, we'll go on to this month's shout-outs. So I will kick off with a mention for Curious, IFR Sciences e-magazine, which is out on Sunday the 29th of March. And it has all sorts of puzzling questions to give you pause. We have Dr. Alfredo Carpenetti exploring how do we actually know the Earth is tilted? I've always thought this, like...
How do we
Where did you begin with that?
All your marbles are just running off the table.
Alf will explain all for you. I also dive into what science has to say about what came first, the chicken or the egg. And Elle, I believe you had a very curious conversation with some people about flamingos.
Yes, I posed the hypothetical question, could you turn a flamingo blue, to some very lovely people from Whipsnade Zoo. So I spoke to Amanda Ferguson, who is the Diet Management Officer for Whipsnade and ZSL London Zoo, and then also Tim Savage, who is the Section Manager of Birds. So he is sort of day-to-day caring for the flamingos, and it was such a fun conversation, and they really humoured me, all my silly little questions. I won't spoil it because it's in the magazine, and it's also going to be a podcast coming out later this year, but it's really fun to kind of dig into the nitty-gritty of why flamingos are pink and whether we could have sort of any influence on that. I'll get our editor Chris to put in a cheeky little short snippet of a little part of the conversation. And so, Amanda, this is probably where you come in. How do you decide what you're going to feed a group of about 40 flamingos at the zoo?
Well, we kind of gather data, really. The most important thing is looking at what these animals would eat in the wild, looking at their natural diet, looking at the kind of nutritional composition of that diet. So that gives us a really good idea about what the animals should be eating when we have them in managed care. We also look at what other zoos have done, what other zoos that have been very successful with their birds. So they've kind of kept them a long time, they've kept them healthy, and they've bred them successfully. So we would use that information as well. And of course, we've got a lot of information from all the keepers that have been at London and Whipsnade Zoo as well, and they've worked with different birds. They may have tried different diets. So they've got a lot of really useful information as well. So we kind of bring all that together and then decide kind of what kind of food items we want. We do some calculations to work out how much they need to eat, depending on their kind of metabolic rate and their body size and their activity. So we get a vague idea of how much to eat, because we don't want to waste food and we don't want to encourage pests by having too much. But of course, we want them to be a really lovely, healthy weight, good body condition. So it's kind of a mixture of all those things that help us decide what we feed them. And then, of course, we're relying on the keepers and like Tim's brilliant team to look at the birds like every day and assess them and tell us, you know, how they're doing. Are they looking a bit thin? Are they looking a bit overweight? Are their feathers in good condition? Are they breeding? Are they behaving in the way we'd expect them to do? So all of that feedback, again, means that we can give like little adjustments to the diet as well to make sure we get it just right.
Then just finally, there's also a fun excerpt in the magazine about why seeing magnolias is a bit like being in Jurassic Park. This is taken from a book called How Flowers Made Our World by biologist David George Haskell. So I feel like there's some lovely stuff for spring.
Yeah, I love a magnolia. There's quite a lot out right now. It's the perfect time of year.
Absolutely. And what's going on? I believe you've got some weird freaky robots for us.
Yeah, this is just a little shout out because I love a silly video. We all know that. And any excuse to talk about this. This is Tom's article, Tom Hale, and it's just, they look bizarre. Imagine like a ball with a stick coming off it out of both ends. Not that unusual, but these have actually been developed inside a computer. They were evolved and they sort of used an AI-driven program that mimics natural selection. So the team plugged in loads of like super simple robot designs built on this sort of modular approach with the ball and the sticks coming off it. And then the algorithm generated these wacky body types. And if a human did this, they would probably come up with something a little bit like a dog or something like really recognizable. But this algorithm had none of the same ideas, and they look super weird, but also they move in a super weird way. I think they sort of wanted to break the mold of like what a robot could be or how it could move. So it's not necessarily about whether it's moving in an efficient way. It's just about the fact that it's been designed by this algorithm and then built by these roboticists. I think it's the University of Northwestern. And yeah, it's really fun. They're very strange. I don't know what you would use them for, but they're doing all sorts. They're doing the most.
I don't think the algorithm took into account like suffering. these robots, they look like they need the mercy rock. It's just struggling along.
Like they just look a bit nuts.
I don't know what it is. It doesn't know what it is.
Yeah.
Everyone's frightened.
The other good thing is that they don't move that fast, so you could be frightened, but you could leg it a lot quicker than they can.
Yeah, if this is the AI takeover, we're going to get out fine, guys. Don't worry. just find the first set of stairs.
Is that everything? Is that all we have to say for 4 weeks of science?
I mean, there's so much more, but people need to get on with their lives.
They can't listen to us jibber jabber the whole time. But as ever, thank you very much for listening. If you want to look at, read, listen to, see, a lot of the things we've talked about will be in visual form in the YouTube version of this podcast. But if not, all the links will be in the episode descriptions. And we will see you next month for another episode of Break It Down.
Catch you next time.
Bye.